Hello and welcome back. We are now at the beginning of section 3. In this section, we will learn how to work with comparison operators. With comparison operators, we can compare values to return either a true or false statement. These comparison operators are equal, less than equal, greater than equal, not equal, in, or not in. At the end of this section, we will then have a few practice questions to test what you've learned in this section, along with a step-by-step solution video. In the next video, we will begin with equal. See you then. Hello and welcome back. Here's a little exercise I would like for you to try on your own. Please try to solve the following queries. Find events with a starting fee equal to 600. Find events with a starting fee less than equal to 500. Find events with a starting fees greater than 400. Find events with a starting fee greater than equal to 300. Find events with a starting fee not equal to 450. Find events with a starting fee in the $400 and $500 category. Find events with a starting fee not in the $300 or the $400 category. Please try to solve all of these on your own. In the next video, I will create a solutions video going over each problem step by step. See you then. Welcome back. In the last video, you were given the challenge to complete these 7 queries on your own. Let us now go over each one step by step and try to find the solution. Query number 1. Find events with a starting fee equal to 600. If we are looking for starting fee, then we need to work with the book fee collection. First, let us look at everything inside of the book fee collection. We can do this by finding all of the information with the following command. db, the name of the collection, period, find, parentheses. This will give us everything that is inside of the book fee collection. We're looking to find events with a starting fee equal to 600. db, period, book fee, period, find, open parenthesis, open curly bracket, starting fee, open curly bracket, equal 600, closing curly bracket, closing curly bracket, closing parenthesis. Verify that everything is correct. We are requesting information from the book fee collection to find starting fee equal to 600. Hit enter, and we return with the event type of festival that has a starting fee of 600. Query number 2. Find events with a starting fee less than or equal to 500. We are working with the same collection, therefore db, period, book fee, period, find, starting fee, less than or equal to, less than equal to 500, closing curly brackets, closing parenthesis, book fee find start-in fee less than equal to 500. Hit enter, and we return with all of the different event types and the start-in fees that is less than or equal to 500. Number 3. Find events with a start-in fee greater than 400. DB period book fee period find open parenthesis open curly bracket start-in fee semicolon open curly bracket we are looking for greater than GT semicolon greater than 400 closing curly bracket closing curly bracket closing parenthesis. Book fee find a start-in fee greater than 400. Hit enter, and we return with every event type that has a fee greater than 400. Next, find events with a start-in fee greater than equal to 300. This is the same. So we can edit the same statement. DB book fee find the start-in fee greater than equal to. And the way I got the statement back is you hit the up arrow and you can delete from the end of the statement. You can delete or hit backspace until you get to the correct position. Greater than equal to 300. Closing curly bracket, closing curly bracket, closing parenthesis. Hit enter, and we are given everything that is greater than or equal to 300 when it comes to the different types of events. Next, find events with a start-in fee not equal to 450. So this time we are looking for everything except events that has a start-in fee equal to 450. DB period book fee period find start-in fee semicolon open curly bracket not equal semicolon 450 closing bracket closing parenthesis. DB book fee find start-in fee not equal to $450. Hit enter, and we return with everything else in the collection except the one event that is not $450. Next, find events with a start-in fee in 400, 500 category. So this is asking us to look for start-in fees, more than one start-in fee at a time. And we can do this by using an array. To use an array, we will just contain all of the different values inside of squared brackets. Let's try. DB dot book fee find start-in fee semicolon in 400 separated by comma 500 brackets close in curly brackets, close in parenthesis, hit enter, and we return for everything that has a starting fee of 400 and a starting fee of 500. Next, find events with a starting fee not in 300 or 400 category. So this is exactly the same as we did right here. So hit the up arrow and the same command will reappear. You can then hit backspace until we get to the part we need to edit. In this case, we are working with the same collection and we are looking for the same value type, the starting fee. In this instance, we are looking for not in. So not in is $NIN. Not in. Brackets 300 separated by a comma 400 closing brackets, closing curly brackets, closing parenthesis, hit enter, and now we return for everything, all of the starting fees except for anything belonging to the 300 range, the 300 category or the 400 category. This completes our section with comparison operators. In our next section, we will begin working with logical operators. I'll see you then. Thank you. In this lesson, we will learn about the equal comparison operator. Comparison operators are operators that compare values and return true or false. The equal comparison operator is used in the following manner. We use the symbol, the $, followed by the abbreviation of EQ. It compares two values and returns true when the values are equivalent, returns false when the values are not equivalent. Let us try an example. First, find any musicians whose birth year is 1990. In other words, find any musicians whose birth year is equal to 1990. To find this information in our music database, we need to work with the musician collection. The musician collection has information about musicians, their name, their instrument or skill, and their date of birth, the year they were born. Let us take a look in MongoDB. As you can see, I entered the command db musicians find. This retrieves all of the information from within the collection. We have 8 different musicians, starting with ID 1 all the way to ID 8, and we have the year that they were born. We're looking to retrieve any musician whose birth year is 1990. We can scan through our database because we're working with a very small database in this class. Normally, if you have a very large database, you will not have time to scan through the database. You will just have to write the command and retrieve the information that you were looking for. But let's spend some time and look through our database quickly because it is a micro database. It is very small. So we have musicians who were born in 1991. Here's one person who was born in 1990. And here's another who was born in 1990. So when we write the query to retrieve this information, we should have a result of 2. Let us start. To retrieve the information, we will use the db command followed by the name of the collection, which is musicians, find, open parenthesis, open curly bracket. In this case, we're looking to find the year they were born. We can identify the year they were born by using the born variable. born, semicolon, curly bracket. Within the curly bracket, we will indicate the comparison operator we are looking to use. In this case, we are looking to find the birth year equal to 1990. To search by equal, we use the $ symbol followed by the abbreviation EQ. Equal, semicolon, 1990. Close in curly bracket, close in curly bracket, close in parenthesis. Verify everything is correct. Musicians, period find, open curly bracket, open parenthesis, open curly bracket, the information we are looking to retrieve, which is born, equal to 1990. Close in curly bracket, close in curly bracket, close in parenthesis, hit enter, and we return with the two musicians we identified previously. ID number 3, Danny Brown, 1990. ID number 6, Jeff Kelly, 1990. Here's another. Find any musicians whose birth year is 1988. So just like the example we just tried, can you pause the video now and try to solve number 2 on your own? Once you have completed, continue the video and I will solve this together. Now, assuming you pause the video and you try to solve this question on your own, let's go ahead and solve it together. So basically, this is exactly the same as we did before, but instead of looking for 1990, this time we're looking for the birth year equal to 1988. We can just hit the up key and scroll over to 1988 and retype the command. Close in curly brackets, close in parenthesis, database musicians, period find, born equal to 1988. Hit enter. And this time we will be returned with one musician. ID number 2, Larry Kent, born 1988. In the next video, we will continue learning about comparison operators using less than or equal to. See you then. Hello and welcome back. In this lesson, we will continue to learn about the less than comparison operator. The less than comparison operator selects the documents where the value of the field is less than the specified value. Let us take a look at a few examples. Here's our musicians collection. In the musician collection, we have different musicians from ID 1 to ID 8, and they have different date or years that they were born. We have musicians who were born from 1998, and we have musicians who were born as early as 1988 and born as late as 1998. Now let us find musicians who was born before 1990. Before is the same as less than 1990. To do this, we can say DB period musicians, which is the name of the collection, period find born. This time we are looking for less than. Symbol, $, less than, semicolon, 1990. 1990 is the specified value that we are looking for other dates less than 1990. Close the statement with curly brackets. two curly brackets because we had two curly brackets opening. So we need to close with two curly brackets and a closing parenthesis. Hit enter. And we return with all of the information about musicians who were born before 1990, whose date of birth is less than 1990. And we have two who were born in 1988. Let us try the second example. It will be the same exact format, except this time the specified value is 1994. DB period musicians period find. We're looking to find musicians who were born less than symbol $, LT semicolon 1994. Closing curly brackets, closing parenthesis. Verify musicians period find open brackets less than the $ symbol LT semicolon 1994 close in curly brackets close in parenthesis hit enter. And this time we have a wider range of values that was returned. We have 4 different members who were born who was born before 1994, whose date of birth is less than 1994. This is how you use the less than comparison operator. Same like the equal comparison operator, we name the collection we are searching to find, we specify the value or the field we are looking from, and then we specify the value. In this case, we will look in to find members who were born less than the specified value of 1990. In this example, members who were born less than the specified value of 1994. In the next video, we will continue learning about other comparison operators. I will see you then. Thank you. Hello. In this video, we will learn about the less than or equal to comparison operator. The less than or equal to comparison operator compare two values and return true when the first value is less than or equivalent to the second value. False when the first value is greater than the second value. Let us try an example. Find musicians born before or during 1988. This is asking us to find any musician who was born in the year 1988 or before, less than or equal to 1988. Let us try in the MongoDB console. DB musicians period find open parenthesis open curly bracket born semicolon open curly bracket less than equal to abbreviation LTE semicolon 1988 close in curly bracket close in curly bracket close in parenthesis. Verify the code. Database musicians period find any musicians whose birth year is less than or equal to 1988. Find musicians born before is a keyword for less than 1988. during 1988, or equal, less than, or equal to 1988. Hit enter, and we return with 4 different musicians. One was born in 1988, the other 1985, 1987, and 1984. And we can verify that this is correct by looking at the musicians collection. And here we have all of the musicians and the year they were born. And these are the ones who were equal or less than 1988. Can you try this example? Find musicians born before or during 1991. Pause the video, try to find a solution, and continue once you are ready. I will go over the solution together, step by step. Okay, assuming you paused the video and tried this on your own, let us now find any musicians born before or during 1991. Exactly like we did before, let us do the same thing, but this time edit the code to look for 1991 or before. Database, musicians, find, open parenthesis, open curly bracket, born, semicolon, open parenthesis, abbreviation for less than or equal, LTE, semicolon, 1991, closing curly bracket, closing curly bracket, closing parenthesis. We are searching musicians to find any musician born less than or equal to 1991. Anyone born in the year of 1991 or before 1991. Hit enter, and we return with everyone who was born in 1991 or before. Therefore, there will be no dates here after 1991. In the next video, we will continue learning about greater than or equal to. Actually, we will learn about greater than first. See you then. Welcome back. In this lesson, we will learn about the greater than comparison operator. The greater than comparison operator compares two values and returns true when the first value is greater than the second value. False when the first value is less than or equivalent to the second value. Let us try an example. Find any musicians born after 1988. Let's look at everything inside of the musicians collection. So we're looking for 1988 and after. Here's one. Well, 1988 is not going to count because we're looking for after. So 1991, 1990, 1994, 1990, and just those 4. So to find this information, we will do database, the name of the collection, find, open parenthesis, open curly bracket, born, semicolon, curly bracket, abbreviation, Abbreviation for greater than, $, followed by GT. Born, 1988. Verify the code. We're selecting from database the collection musicians. We're looking to find any musician born after 1988. Hit enter. And we return with the 4 musicians we identified before we ran the command. Let us try another. Find any musicians born after 1990. Pause the video and try this query on your own. Once you have tried it, continue the video and I will solve this query with a step-by-step solution. Assuming you have tried to solve this query, now let us find any musicians born after 1990. And by now, you should know it is identical to what we did previously. The only piece of information we have to change is the year that we are looking for. This time, we are looking for musicians born after 1990. Hit enter. And we return with every musician on file who was born after 1990. In the next video, we will learn about the greater than or equal to comparison operator. See you then. Welcome back. In this lesson, we will learn about the greater than or equal to comparison operator. The greater than or equal to comparison operator compares two values and returns true when the first value is greater than or equivalent to the second value. False when the first value is less than the second value. Let us try an example. Find any musicians born during 1990 or after. In other words, we are looking to find any musicians who was born after 1990 or equal to. Let us try to find this. In MongoDB, use the command db musicians, which is the name of the collections, find curly bracket born curly bracket greater than equal to. Just like less than equal to, greater than equal to is GTE. Greater than equal to semicolon 1990. Close in curly bracket, close in curly bracket, close in parenthesis. Hit enter. And this time we are returned with information about every musician who was born after 1990, including 1990. So we have everyone who was born in 1990, during 1990, and everyone who was born after the year 1990, which is 1991 for musician number 1 and 1994 for musician number 5. Can you please try to find any musicians born during 1991 or after? Pause the video and try to solve this query on your own. When you're ready, continue the video and I will solve the query step by step. Assuming you have paused the video, to solve this query, find any musicians born during 1991 or after. It is exactly the same as we did before. we will use the command db musicians find open parenthesis open curly bracket born semicolon open curly bracket greater than equal. The abbreviation is $GTE semicolon 1991 and the statement with two curly brackets and with a closing parenthesis. Hit enter and we return of all musicians who was born during 1991 and after greater than or equal to 1991. We have musician number 1 born 1991 and musician number 5 born in 1994. In the next video, we will continue learning about not equal to comparison operators. I will see you then. Thank you. Hello and welcome back. In this video, we will begin to work with the in comparison operator. The in comparison operator selects documents where the value of a field equals any value in a specified array, more than one value. Let us try an example. Find all musicians who have experience with drums or guitars. First, let us look at the musician collection. Enter the command db musicians find, followed by parentheses. Hit enter, and we have a list of everyone who exists within this collection. We have 8 different musicians, and we can tell the type of instrument that they are known to play. In this case, we are looking for all of those. Find all musicians who have experience with drums or guitar. So we're looking for everyone who either play a drum or a guitar or both. Let us write this query together. db period the name of the collection, which is musician, period, find. This time we are looking to find instrument. Semicolon. The abbreviation for in is $IN semicolon. And this time we are looking to find information about drums or guitars. We're looking for 2 pieces of information. Therefore, we're going to search by using an array. And to search by using an array, we will use square brackets. Within the square brackets, we can separate each value with quotations and a comma. First, open square bracket and type drums. Verify that it is in quotations, followed by a comma. Then type guitar. End it with a square bracket and with the closing curly brackets and the closing parenthesis. We are searching for musicians. We are looking to find any musician who has experience. All musicians who have experience with drums or the guitar. Being that we are searching for more than one value at a time, we are searching as an array which is set up within brackets. Each value is within quotations, separated by a comma. If you're dealing with a number, the number does not have to be within quotations. Hit enter. And as a result, we are returned with every single artist, every single musician on file who has experience playing the drums, the guitars, or even both. Well, there's no one who plays both. Everyone plays either or. Let us try another example. Now, can you try for all events for those using the book fee collection, find all events that are either a wedding or a banquet? Try this on your own, pause the video, try this on your own, and hit continue once you have tried to solve this. In the next section, I will solve this query step by step and go over the solution. Now, assuming you have paused the video and you have tried, first let us look at the book fee collection. So far, we have been working with the musicians collection, but now let's switch it up a little. Let us begin to work with the book fee collection. Enter the command db period book fee period find parentheses, hit enter. You will see all of the information we have within our book fee collection. We have information about the different type of events and their starting fee. Now, we're looking to find all events for those in weddings or banquets. So anything that's a wedding or banquet, we're looking to get information about. We can do this by using the following command. Hopefully, you were able to solve this query. If not, please pay attention. It is very similar to all of the queries we have previously written. First, enter the database period by the name of the collection, which is book fee. Period find. This time, we're looking to find any type of event that is a wedding or a banquet. So we can do within commas type, semicolon, curly brackets, the abbreviation for in. And again, we are searching by an array. So we need to have brackets, and the values we are searching by. In this case, we are looking for weddings and banquets. Closing square bracket, closing curly brackets, closing parenthesis. db period book fee period find. We're looking to find the type of event in either weddings or banquets. Hit enter. And we are returned with the type of events that matches banquets or weddings. And we have banquets starting at $450 and weddings starting at $400. Now let us try one more thing here. If I were to scroll all the way back and I hit the backspace button and backspace, I went ahead and I entered quotations between around type when I entered the value. Now if you were to remove the quotations, hit enter, you will see that it worked exactly the same. As long as you followed the same format it was entered while creating the collection, It will work with or without quotations. In the next video, we will continue learning about comparison operators. Finally, we will learn about the not in comparison operator. See you then. Hello and welcome back. In this video, we will learn about the not in comparison operator. The not in comparison operator finds documents where the field value not in the specified array or the field does not exist. This is very similar to the previous lesson, the in comparison operator. The only difference, instead, we will be looking for fields that are not in a specific array. Let us try an example. Using the same exact queries we used from the previous lesson, this time, let us find all musicians except for those who plays drums and guitars. If you can recall, before we were only looking for musicians who play drums and guitars. This time we're looking for everyone else except for musicians who has played the drums or the guitar. In the MongoDB console, first, let us look at the musician collection. And we have a few. We have drums, guitars, drums. So we're looking to retrieve everyone else who plays something opposite or something other than a drum or a guitar. To do this, we will write the very same command. db period musicians find instruments semicolon not in. Their abbreviation for not in is not, N-I-N, not in. We are still searching for or by an array. Therefore, we need to use square brackets, the name of the value separated by comma. Closing square bracket, closing curly brackets, closing parenthesis. We are looking to find information about musicians except for anyone who has played the drums or the guitar. The command we are searching by is db period musicians period find instruments not in drums or guitar. Hit enter, and we return with all of the musicians except for anyone who has ever played the drums or anyone who has ever played the guitar. Here's another. Find all events except for weddings and parties. Please try this query on your own. Pause the video and try to solve this query. When you continue, I will go over the solution step by step. Okay, assuming you have tried that, let us continue. This time, we're looking to find all events, except for weddings and parties. Well, we know that we have information about weddings and parties inside of the book fee collection. Therefore, we need to use book fee. db period book fee, period find, parentheses, hit enter, and we return with the different types of events that we have stored within our book fee collection. We have different types of events, and we have the different start-in fees. So this time we're looking for all events except for weddings and parties. To do this, we will type db book fee find. This time we are looking for everything other than weddings and parties. Type semicolon, curly brackets, abbreviation for not in, semicolon, square brackets, and the name of the values that we are looking to exclude. In this case, it is weddings and it is parties. Closing bracket, closing curly brackets, closing parentheses. Verify that the statement is correct. db period book fee period find. The type of events that we're looking that is not in weddings, not in parties. Hit enter. And this time we returned with all of the events and their start-in fees except for information about weddings or parties. We have now completed the section about comparison operators. In the next video, I will provide you with a short practice summary of a variety of questions. This way, you will be able to test your knowledge in everything you have learned this far in this section before we continue to the next section, which will be logical operators. See you then. Welcome back. In this video, we will learn about not equal to comparison operators. The not equal to comparison operators compares two values and return true when the values are not equivalent, false when the values are equivalent. Let us try an example. Find all musicians except for those born in 1990. So first, looking at the musicians database, the musicians collections, we can retrieve everything within this collection by typing the command db period musicians period find parentheses. This allows us to see everyone who is part of this collection. We have 8 different musicians from ID number 1 all the way to ID number 8. This time we are looking to find any musicians, all musicians born except for those born in 1990. So we currently have 2 musicians that was born in 1990. So we would like to write a query to retrieve information about everyone else except for musician number 3 and musician number 6. To do this, we will type the command db period the name of the collection, which is musicians, period find, open parenthesis, open curly bracket, born. The abbreviation for not equal is N for not, E for equal, not equal, semicolon, 1990. DB musicians find any musician born except for those in 1990. So we're looking for musicians born whose birth year is not equal to 1990. Hit enter. And we return with every musician inside of our database except for musician number 3 and for musician number 6. Can you please try the second query? Find all musicians except for those born in 1984. Follow the example like we just did. It is exactly the same. You just need to edit one line of code. Pause the video, try to solve this query, and continue once you are ready. I will then solve the query with a step-by-step solution. Okay, assuming you have paused the video and tried this query on your own, let us solve it together. We are looking to find all musicians except for those born in 1984. So the same way we solved the previous query, we will use the same command because we are working with the same collection and we are looking to get the same piece of information, except the date of the information is now different. The request is different. This time we are looking for 1984. DB period musicians find born not equal 1984. DB period musicians period find. We are looking to find musicians born except for musicians born in 1984. Hit enter. And we return with all musicians except for those who was born in 1984, not equal to 1984. In the next video, we will continue learning about comparison operators. We will begin to work with the in operator. See you then. Hello and welcome back to MongoDB, the Beginner's Bootcamp. We are now in section 4. In this section, we will learn about logical operators and how to work with AND, OR, NOT, and the NOR operator. In the next video, we will begin working with the AND operator. Also, at the end of this section, we will then have a short exercise to review everything you have learned in this section. I will see you then. Thank you. Hello and welcome back. In this lesson, we will learn about the AND logical operator. The AND logical operator performs operation on an array of 2 or more expressions and retrieves the document which satisfies all of the expression in the array. If the first expression evaluates to false, MongoDB will not evaluate the remaining expression. Let us try an example. First, find any musician who plays the drums and was born in 1998. So in order for us to write this query and to get the correct result, we need to find musicians who plays the drums and was born in 1998. Both of these conditions must match, must be true in order for this query to run. Let us try. We are working with the musician collection. First, we can look at everything that exists within the musician collection. Then, we can go ahead and write the query. So to write a query using the AND logical operator, we will start it like any ordinary query. DB, the name of the collection, find. This time we need to use AND. A-N-D, AND. We are looking for more than one value from within an array. It is an array, so we need to have a square bracket. Within the square bracket, let's first identify the first value we are looking for. The first value has to do with someone who plays drums. Drums is stored under instruments. Instrument, drums. Second, we are looking for someone who was born in 1988. Born 1988. Close in curly bracket, then close in two more curly brackets to close the statement, close in parenthesis. So in this case, we are looking for two values. Both of these values must be true. Someone must play the drums and they must have been born in 1988. Hit enter. And we return with an error. So let us troubleshoot this together and find out exactly what error did we make. So let's type the sequence again. DB musicians, period, find, open parenthesis, open curly bracket, and semicolon, square bracket, curly bracket, instrument. Semicolon, drums, closing bracket, comma, open bracket, born, semicolon, 1988, closing bracket, closing curly brackets, close in parenthesis. So it looks like everything is correct. Let us go ahead and hit enter and see what happens. Oh, I see what happens. I see the mistake. Right here. There's a closing bracket for instrument and drums, and there's a closing bracket for born in 1998 right here. Except I need to have a closing square bracket, and I didn't. So space, closing square bracket, closing curly bracket, closing parenthesis. So let us look at this again. Open parenthesis, closing parenthesis, open curly bracket, closing curly bracket, open square bracket, closing square bracket, open and close, open and close. Everything matches. Hit enter, and this should work. And there you go. We'll return with ID 2, Larry Kent, who plays the drums, and keyword and was born in 1988. Now, we took a few extra minutes there because we needed to debug this code. We needed to verify exactly what was the error. And the error was, instead of having a closing square bracket, I had an additional closing curly bracket. As a developer, regardless if you're a new developer or an expert who has many years in the field, you will make errors. And you also have to learn to take the time and backtrack your code. Be able to look at the code and find out exactly what the error is. Sometimes the console will give you a hint. And it did. It says syntax error, missing square bracket. I see it now. I didn't catch it immediately, and I didn't think of looking for it immediately because I thought, let's just go and look at the code and backtrack everything that we did together. So sometimes look at the error messages, read them, and try to understand to see if you can debug whenever you're faced with an error. Let us continue. Query number 2. Find any musician who plays the drums and was born before 1990. So this is almost the same as the previous one, except there's a small condition. The condition is was born before 1990. Please pause the video now and see if you can solve this query on your own. When you're ready, hit continue and we will solve it together. Now, assuming that you paused the video and you tried to solve that query, let us solve it together. We are looking for any musician who plays the drums and was born before 1990. So we can hit arrow up to get back to the same query we wrote previously, except this time we can backspace until we get to born. When we get to born, add a semicolon and a curly bracket. Inside the curly bracket, use the abbreviation, the comparison operator, less than. Less than is the same as before. Less than, semicolon, 1990. Close it, curly bracket, square bracket, curly bracket, closing parenthesis. So this time we are looking for musicians who plays the drums and who was born less than 1990. In other words, born before 1990. Hit enter. And it looks like I made another error. Let me see. Born less than 1990. Closing bracket, closing bracket, square bracket, closing curly bracket, closing parenthesis. And my error was a closing bracket here. I left one out because now we have open bracket, so we need to have closing bracket, closing bracket. Go ahead and hit enter, and this is guaranteed to work. And there we have it. Now we have information about musicians who plays the drums and was born before 1990. In the next video, we will continue learning about the OR operator. I'll see you then. Welcome back. In this video, we will learn about the OR operator. The OR operator performs a logical OR operation on any array of two or more expressions and selects the documents that satisfies at least one of the expression. Unlike the AND operator, only one of the expressions has to be true in order for something to be returned. Let us try an example. First, find any musicians who plays the drums or the bass. First, let us look at the musician collection. Here we have a list of all of the musicians and we can see what instruments they play. So we are looking for anyone who plays the drums or the bass. To do this, we will enter the command db period, the name of the collection, find or the $ or square bracket, curly bracket, instrument, closing bracket, period, instrument, bass, closing bracket, closing square bracket, closing curly bracket, closing parenthesis. So this time, we're looking for anyone who plays drums or the bass. Unlike the AND, only one of the statements has to be true in order for something to be returned. Hit enter. And we are returned with everyone who plays the drum or the bass. Let us try one more example. Find any events with a starting fee of $500 or $600. Events with a starting fee of $500 or $600. In order to get information about events and starting fee, we need to work with the book fee collection. If you enter the command db period book fee period find, we are given a list of all of the information that exists within this collection. We have different type of events and we have different starting fees. In this instance, we are looking for a starting fee of $500 or $600. Can you please pause the video and try to solve this query on your own? Find any events with a starting fee of $500 or $600. When you continue, we will solve this together. Okay, assuming that you paused the video and you're now ready to continue, let us solve this query. We are looking for events with a starting fee. So we need to search by starting fee. $500, $600. DB book fee find starting fee find starting fee 500 and 600. However, I made a mistake. Did you catch my mistake? I forgot to enter the operator. DB book fee find open parenthesis open curly bracket, or from an array open square bracket close square bracket. There's two values within curly brackets separated by a comma. Verify that all of the syntax, all of the brackets are correct, and then hit enter. And we then return with both of the two different events, which is a parade, start-in fee $500, or a festival, start-in fee $600. In the next video, we will continue learning about operators. We will continue by learning about the not operator. See you then. Hello and welcome back. In this video, we will learn about the not operator. The not operator inverts the effect of a query expression and returns documents that do not match the query expression. Let us try a few examples. First, find all starting fee not greater than 500. So we are looking for the book fee collection. Inside of the book fee collection, we are looking to find all of the starting fees that is not greater than $500. Let's try this. First, let us look at the book fee collection. And we're looking to find starting fees that is not greater than 500, not greater. Abbreviation NOT, $ followed by NOT. Not greater. Not greater means we need a second set of curly brackets, and we also need to indicate the greater than comparison operator. Not greater than 500. Close in curly bracket, close in curly bracket, close in curly bracket, close in parenthesis. Go ahead and verify that everything is correct. We are looking for information from the book fee collection. In the book fee collection, we are looking for starting fees not greater than 500. Hit enter. And we return with everything up to 500. 300, which is not greater, all the way to 500, which is also not greater than. Anything 501 or above will be considered greater than. Let us try the second example. The second example says, find all instruments or scales not equal to vocals. If we look at the musicians table or the musicians collection, we can see that we have a list of different musicians and the different type of instruments or skills that they can perform. In this case, we are looking for someone whose skills or instrument is not equal to vocals. DB, collection name, find, open parenthesis, open curly bracket, instrument, not equal, to vocals, closing curly bracket, closing curly bracket, closing curly bracket. We need 3 closing curly brackets because we have 3 opening curly brackets, so we need to close them. Closing parenthesis. Verify the syntax and the code. DB musicians find instrument not equal to vocals. Hit enter. And everything except vocals is returned. We have drums, bass, guitar, keyboards, drums, and bass. Everything except vocals is returned. In the next video, we will continue learning about logical operators. There's an operator I would like to speak to you about. It is called between. It is not a real operator in MongoDB. However, there's a way that we can write our query to find a range of a given value. I will see you in the next video. Thank you. Hello and welcome back. In this video, we will learn about the NOR operator. The NOR performs a logical NOR operation on any array of 1 or more query expressions and selects the documents that fail all the query expressions in their array. Let us try a few examples. First, find all musicians who was not born in 1990 or do not have vocal skills. Find all musicians who was not born in 1990 or do not have vocal skills. Let us try this example. First, we need to work with the musician collection. And we are looking for anyone who was not born in 1990 or do not have vocal skills. To do this, we will say DB period musicians period find open parenthesis open curly bracket NOR abbreviation $NOR followed by the semicolon and a square bracket because we are looking within an array. First value instruments, vocals, close the first curly bracket separated by a comma, curly bracket, born 1990, close curly bracket, close square bracket, close curly bracket, close parenthesis. Verify that everything is correct. We are looking for musicians who do not play the vocals or do not have any skills when it comes to vocal talent, or who was not born in the year 1990. In this case, we are using the NOR operator. Hit enter. And we return a list of all of the musicians and neither one of them have vocals listed in their instrumental skills, and neither one of them was born in 1990. Let us try another example using a different collection. Example number 2. Find all events except for weddings or a starting fee of $500. In this case, we will work with the book fee collection. Please pause the video now and try to solve this query on your own. Okay, assuming you paused the video and you tried this on your own, let us go ahead and write this query together. In this case, we need to work with the book fee collection. In the book fee collection, we are looking to find nor from within an array. A type, weddings, close the curly brackets separated by comma. The starting fee of $500. Close the curly bracket, close the square bracket, close the curly bracket, and then close the parenthesis. Verify that all of the syntax and brackets and everything else is correct. We are looking for book fee from the book fee collection. We are looking for the type, which is weddings, nor the type or nor an event with a starting fee of $500. Go ahead and hit enter. We then return with a list of all of the different types of events. None of them returned are a wedding, and then none of the starting fees are $500. Therefore, both of these were excluded from our return. In our last video, I mentioned that I was going to go over a brief example to show you how to find a range from within a query. Now, MongoDB does not have a between operator the way that SQL does. We cannot look for something where a certain value is between a specific range. What we can do is we can use the comparison operators that we already have. And let me show you exactly what I mean. For example, let's say we were looking at the musicians database. And we have a list of different musicians. We have musicians who were born as early as 1984, and we have musicians who were born as late as 1994. Now, what if we wanted to select musicians between a specific range? We can do this. We can say db.musicians period find born. For example, let's do this with the year they were born. Born. The first, we're looking for people who were born after 1985. So greater than 1985. And we're looking for people who were born before 1990. Less than 1990. Close the statement with two curly brackets and a closing parenthesis. Now let us verify. We are looking for musicians who were born greater than 1985, who were born after 1985, and who were born less than 1990, who was born before 1990. So we are only looking for people above 85 and people under 90. Hit enter, and we return. We return with two musicians, one who was born in 1988 and one who was born in 1987. And if you verify here, these are the only two that falls within this specific range. Now, this is a quick example of a way you can search through a range without having to use a between operator like exists within a relational database. We can basically find the range based on the logical operators, and if it will allow us to retrieve information based on the collection and the type of information we are dealing with. Now that we have completed this section on logical operators, I would like you to try these examples on your own. Please try to solve these queries on your own, and in the next video I will create a solution. I will go over the solution step by step and answer any questions, especially if you were stuck. You will be able to see my solution and figure out exactly what the problem was before we move on to the next section. I will see you then. Hello and welcome back. In the last video, I provided you with a series of queries to try on your own. First, let us review the queries, because I don't believe I reviewed them with you, but let's do that now. First query, find all musicians whose ID is greater than 5 and plays the drums. Number 2, find all musicians born in 1990 or 1991. Number 3, find all starting fees not greater than 400. Number 4, find all starting fees except for weddings and banquets. Number 5, find all musicians whose ID is greater than 3. Is greater than 3 and less than or equal to 6. Hopefully you were able to try all 5 of these on your own. Now let us go over each one step by step. Number 1 says find all musician whose ID is greater than 5 and play the drums. Therefore, there's an and condition. Therefore, this person, his ID has to be greater than 5, and this person has to play the drums. DB, musicians, find. We are looking to find and. Instruments, drums, and whose ID is greater than 5. ID greater than 5. Closing bracket, closing curly bracket, closing square bracket, closing curly bracket, closing parenthesis. Verify that everything is correct. DB musicians, period, find, and instruments, and, well, drums, and the ID is greater than 5. Hit enter, and we return with anyone who plays the drums, and their ID is greater than 5. Let us try number 2. Find all musicians born in 1990 or 1991. To do this, we can born, but we need to add in our operator, or. Born 1990, separated by a comma. Born 1991, close curly bracket, close bracket, close curly bracket, close parenthesis. So this time we're looking for any musician who was born in 1990 or 1991. Hit enter, and we return with 3 different musicians. All of them were born in 1990 or 1991. Let us try number 3. Find all starting fees not greater than 400. DB period book fee, because we are working with the book collection. Find the starting fee, not. Find the starting fee not greater than $400. We need 3 closing curly brackets, 1, 2, 3, because we have 3 opening, 1, 2, 3. So we need 3 closing, followed by a parenthesis. Hit enter, and we return with all of the starting fees, none of which is greater than $400. Number 4. Find all starting fees except for weddings and banquets. DB period book fee period find, nor type weddings separated by a comma, banquets, closing curly bracket, closing square bracket, closing curly bracket, closing parenthesis. Go ahead, verify that everything is correct, and hit run. Before you hit run, let's just verify. Yes, okay, it is correct. Weddings, banquet, comma, curly brackets. I'm just verifying that we had enough curly brackets. Hit enter. And we return with everything except for weddings and everything except for banquets. The last one, find all musicians whose ID is greater than 3 and less than or equal to 2. Let us try. Looking at the musicians table, we're only looking for anything greater than a 3, so from 4, and less than or equal to 6, so from 4 until 6. DB period musicians period find ID semicolon greater than 3 less than equal to 6. Close curly bracket, close curly bracket, close parenthesis. Verify that everything is correct. Musicians find ID greater than 3 less than equal to 6. Hit enter, and we return with 3 musicians greater than 3, so we're starting with musician number 4, and equal to, less than or equal to 6, so everything 6 and under. We have now completed the section on logical operators. In the next section, we will continue learning about different methods and how to write queries to retrieve data from an embedded array. I will see you then. Thank you. Hello and welcome back. In this video, we will learn about 3 additional aggregate functions in MongoDB, which is limit, exist, and skip. Limit limits the number of documents passed to the next stage. For example, if we were to output everything from within the musicians table, we can limit the number of records we would like to see. Exist. When a Boolean is true, exist matches the documents that contain the field, including documents where the field value is null. If the Boolean is false, the query returns only the documents that do not contain the field. In the example we try, you will see quickly how exist is used. And skip. This should say skip. The skip method is used for skipping the given number of documents in a query result set. It is often used with limit. Now let us combine all 3 together to see how they work together in MongoDB. In MongoDB, first let us try to find an event. Let's first do db period bands period find curly bracket. Let's look for event. And as you can recall, the event was an embedded piece of information we stored when we created the bands collection. Within events, we're searching to see, or within the bands collection, we're searching to see if any events exist. Only return those where no events exist. False. Hit enter. and we return with all of the bands where there's no embedded information. If you would like to see a clearer format of this, you can add pretty to the end of the statement. And what pretty does is it expands the results. Anything with embedded information becomes easier to read. Hit enter. And as you can see, none of these results are expanded because they have no events stored from any previous events where they have worked or provided entertainment for us. Let us try now one with limit. Now we're going to hit up, and hit enter one more time. And as you can see, these are all of the bands that were returned. But let's say we only want to see the first three. 1, 2, 3. This is where limit comes in. Simply, we can add a period and type limit and the number of records we would like to limit the result to. In this case, we'll use a limit up to the first 3 records. Hit enter. And this time we are returned with information only about the first 3. Now, what if we wanted to include skip? What if we wanted to do hit up to get the same command and backspace? What if we wanted to limit 4 records this time? 4 records, but we wanted to skip the first 2. Add period and skip. The number 2, close in parenthesis, hit enter. And this time we are given 4 records, but the first 2 records are not part of our return because we skipped the first 2 and we started with the Valley Moors. If we look at our musician collection, you can see that there's musician 1, 2. Excuse me, I meant to look at the bands collection. Looking at the bands collection, you can see that there is 2 bands and then there's Valley Moors. However, when we limit 4 and we skip 2, the first 2 will be skipped. Then we will start at this one up to 4. And this is what this query returns. Hit enter. And there you go. We have a return result of anyone who does not exist events, meaning any bands who do not have any events on record, because with the exists function we set false. If we were to change this to true, this will only return bands who have events on record, and then everything else is the same. We can limit this to 5, or we can limit this to any number we choose, and we can decide of how many records we want to skip. This is very useful when dealing with a very large database. In our case, we are working with a micro database for a very short class. Therefore, our records are limited. In the next video, we will continue writing queries. In this section, this was a brush up on some of the important aggregate functions that exist within MongoDB. But in the next video, we will continue writing queries. The queries we will focus on will be queries to retrieve information about embedded documents, such as information stored about different events that different bands performed at. I will see you then. Thank you. Hello and welcome back. In this video, I would like to take some time with you to learn how to find aggregate functions like the average, max, or min in MongoDB. Now this will be an intro lesson to these topics. As you become more advanced as a MongoDB developer, you will learn how to write queries with more advanced aggregate functions. First, let us take a look at what an aggregate function is. Basically, an aggregate function calculates aggregate values for the data in a collection or a view. We can calculate values to get the max value, or the minimum value, or even the total, the sum. Let us try a few examples. First, let us look at the book fee collection. In the book fee collection, we have different type of events with different fees, different starting fees. Some as low as 300, some as high as 600. Let us write a query to retrieve information about. Let's start with minimum. Let us write a query to retrieve information about the minimum fee in our book fee collection. To do this, we can create a variable. We can store the minimum function inside of a variable by grouping together all of the IDs from within the book fee collection. When we group all of the IDs together, we can then use the minimum function to find the minimum value. Let me show you exactly what I mean. At the beginning of this course, we created a variable to insert many documents at once. Now, let us create a variable to insert a specific function. In this case, we are looking to insert a minimum aggregate function. Let us create a var. Name this var. Let us name this T1. Var T1 is equal to group. First, we need to use group because we are looking to group together a specific field so we can find the max. And the field we are looking to group together is ID. Group together all of the IDs. Group together all of the IDs, and we are looking to find the minimum. So we are looking to find min, $, starting fee. And by adding the $ before the type or name of the value, in MongoDB, we are indicating that it is some type of counter. Some type of aggregate function will occur. In this case, we are looking to find the minimum value of the starting fee. Close it with 3 curly brackets because we opened it with 3 curly brackets. 1, 2, 3. Now when you hit enter, nothing should happen. Go ahead and hit enter. But before you hit enter, please verify that you have quotations around all, you have a comma, and you have quotations around starting fee. After the quotations, you have a $. Hit enter, and there, nothing has happened. However, the var was created. Now we can take this stored function and we can insert it into our book fee collection. When we insert it into our book fee collection, we will then be returned with a minimum value. Let us do this now. To do this, we will say db period book fee period aggregate. aggregate, aggregate. Within parentheses, we want to tell the system what we are looking to insert. In this case, we are looking to insert the variable we created. The name of the variable is T1. T1. hit enter, and now we return with a minimum value of 300. And if you look at the book fee collection, you can see that we have 300. Now, let us do the same thing for the maximum value. Repeat the same exact steps. Create a var, give it a different name. This time we are naming it T2. Group ID all max. Quotation, $, start-in fee, close in brackets. Check the code. Var T2 is equal group ID all in quotations followed by a comma max $max start-in fee in quotations starting with a $, close in curly brackets, hit enter. And the var was created, and we see nothing else on the screen. Now, we need to insert this information into the book fee collection. We can say db period book fee period aggregate AGGREGATE parenthesis and the name of the var. In this case, for max, we say the name is T2. Hit enter, and this time we are returned with the max starting fee out of all of the events on file. Now let us try this for average. We did minimum, we did maximum. Now let us do average, and it is exactly the same step. If you would like, pause the video and try to do the one for average. When you continue, we will go over the solution step by step. Now, assuming you have paused the video, let us create an aggregate function for average. First, we need to say var, and we need to name this var. Let's name it T3 equal group ID all average AVG for average $AVG semicolon quotation $ start-in fee three close-in curly brackets. Verify that everything is correct. Var T3 group all IDs average start-in fee in quotations starting with a $, close in curly brackets, hit enter, and nothing is returned. Now let us insert this into the book fee collection. db period book fee period aggregate AGGREGATE in parentheses T3. Hit enter, and this time we are returned with the average value of all of the starting fees. This time, the average is $437.50. And this is a good, easy way to start looking at aggregate functions as you learn more about them. In the next video, we will continue learning to write queries, except this time, we will learn how to write queries using embedded documents. I will see you then. Thank you. Hello and welcome back. In this video, we will learn about projection queries. A projection query is a query where you can specify which fields should be returned. 1 will display the field, 0 will hide it. Let us try an example. First, let us use the basic find statement. db period musicians period find. Hit enter, and we return with a list of all musicians that we have on record, information about their name, instrument, and the year they were born. We can add a projection to this query, and it will only return us with an ID and the information we are looking to find. For example, we can say db period musicians period find. Let's find instruments and name. Let's find instruments. Instrument, vocals. Also, let us find name. However, we want to use the projection query to find the name for us. We are not going to enter a name. We are only going to enter either 1 to display the name or 0 to not display a name. Let's enter 1. After you enter 1, close the statement and close it with a parenthesis. Verify that everything is correct. db musicians period find instrument vocals name 1. So what this query does, this query will scan the database. It will look for anyone in the musicians collection who has vocal skills. It will then list us the ID of that person, including their name. And that is the only 2 pieces of information it will return. We are asking the system to project the names of everyone who is a vocalist. Hit enter. And I have a syntax error. Syntax error, I'm missing a parenthesis. So where am I missing a parenthesis? Oh, I'm missing a parenthesis right at the beginning. So db period musicians period find parenthesis curly bracket instrument vocals name, and we are using 1 because we would like to output the name. Curly bracket parenthesis. And I also have a spelling error. This is why it's very good to check your code. Instrument, okay. Hit enter. And this time we are returned with the ID of 1 and 6. And ID 1 and 6 belongs to 1, Robert Van, who is a vocalist, and ID 6 to Jeff Kelly, who is also a vocalist. Now, if we wanted to edit this query to not output the ID, all we had to do is type the following command. db period musicians period find parenthesis open curly bracket instrument vocals. ID. This time we have to indicate the ID that we do not want the ID. Now automatically when you use a projection query, the ID is automatically outputted. If we do not want the ID in our output statement, we have to indicate we do not want the ID. So we type ID followed by a 0. 0 will eliminate the ID out of the query. Name 1. We still want the name. So we are looking with a projection query for vocalists. We are looking for vocalists and we are looking to output their name without their ID. Hit enter. And this time we are returned with the same 2 vocalists with their names, but without their ID. Now, when we are working with exclusions, and an exclusion is when we decide to not output a certain field, we cannot mix and match. We can only mix and match exclusions when we are working with the ID, because the ID is an automatic field. So we can only say no for the ID and yes for anything else. However, if we were looking for the name and for the instrument, we cannot say no to one and yes to the other. We can only say yes to both or no to both. Let us try an example. If we hit up once, up again, actually let us just retype it. Let us retype the entire command. So db period musicians period find, open parentheses, open curly bracket, instrument, vocals. This time, let's say 0 to the ID and 0 to the ID and I'm thinking of a good query. How can we test this? Instead of using 0, let's use 1. Let's say 1 for the instrument, one. If we were to do 1 or 0, so let's do this. Let's do this. I'm sorry about that wait. I'm just looking at the database and I'm trying to figure out what is the easiest way to explain this. So let's say that we are, forget about the ID. Let's say we are looking for the instruments or anyone who has vocal skills. So we already have db musician period find instrument vocals. Then if we want to find the name, we have to type name 1. And if we also wanted to find born, we have to say born 1. Therefore, we can request 2 of the same values at the same time. We can request to have the data retrieved by using 1, or we can request to exclude it by using 0, but we cannot mix and match. We cannot have 1 for name and 0 for born, or either or. It's either we have 1 for both or 0 for both. The only time we can mix around with an exclusion is when we are playing with the ID field. And the reason why the ID is always automatically outputted in MongoDB. The only time the ID will not be a part of the output in MongoDB is if we use exclusion, if we exclude it by indicating 0. Hit enter. And this time we are returned with information about 2 players. Now if we hit the up button one more time and we backspace and we put 0, curly bracket, closing parenthesis, now we have a mix. We have name for yes, output the name, but for born we're saying no. If we mix it and we hit enter, we will get an error. Click enter. And it says projection queries. Projection cannot have a mix of inclusion and exclusion. It's either both are inclusive or both are exclusive. You can only mix inclusion or exclusion when we are dealing with the ID field and a different field name. In this video, we learned how to use projection queries. We also learned how to use inclusive and exclusive commands. In the next video, we will learn how to limit our queries and how to skip a particular part of a collection. I will see you then. Thank you. Hello and welcome back. In the last section, we covered several different topics, such as projection queries and queries including limits, sort, or skip. Before we move on to the next section, I would like for you to practice writing queries using all of the above topics. Please try to answer these queries on your own. And in the next video, I will go over each one step by step. First, find only the names of musicians who plays the drums. Then, find the event type that has a starting fee of $400. List only the event name. Then, find all of the events and their starting fees. List in ascending order. Then, find the 3 highest starting fees. List in descending order. And finally, find the first 2 bands with events. Do not output the first event on file. Print in a friendly format. Please try to answer all of these on your own. In the next video, I will go over the solutions step by step. Thank you. Hello and welcome back. In this video, we will go over the solution to the practice questions from the previous section. First, let us start with number 1. Find only the names of musicians who plays the drums. In order to find information about musicians and the instrument they play, we need to work with the musician collection. First, let us look at all of the information inside of the musician collection. We can do this by using the db musicians find parenthesis command. Hit enter, and we return with all of the information that exists within this collection. However, by using the basic find command, we are given all of this information, but this query is asking us to only find the names of musicians who play the drums. And the easiest way for us to output or to find a list of only the names of musician who plays the drums is by using a projection query. To use a projection query, we will write the command in the same format, db:musicians find. In this case, we are looking to find instruments. Which is the drums, and we are looking to output only the name of musicians who play the drums. This is a projection query. We are looking to project information about musicians from the musician collection who plays the drums. Information about the type of instrument played is stored under instrument. We are looking to project only the musician's name. Hit enter, and we return with the three different musicians who plays the drums. We are also automatically returned in every projection query the ID of that specific individual or item. If we do not want the ID to output, and this is what our question is asking us for, to find only the names of musicians who plays the drums, we can change the query to indicate to only print the names. Hit the up arrow, and we can backspace right before name, and we can add ID 0 separated by a comma. By adding ID and specifying 0 means that we know the ID is automatically printed. However, in this case, we do not want it to display. Hit enter, and this time we are only returned with the names of musicians who plays the drums. And this is specifically what we were looking for. Find only the names of musicians who plays the drums. Let us try number 2. Find the event type that has a starting fee of $400. List only the event name. Similar to number 1, in this case we are looking to list only the event name. So this is also a projection query, and we will also exclude the ID field from our return. Let us try this. To find information about event type or starting fees, we need to work with the book fee collection. book fee find. Hit enter, and we have a list of the different type of events and their different starting fee. In this case, we are looking to project the name of the event with a starting fee of $400. book fee find, open parenthesis, open curly bracket, starting fee of $400. We do not want the ID to automatically output. And we do not want the starting fee of $400 to output. We only want the event type name. Therefore, we're using book fee find. We're looking to find the starting fee of $400. We do not want to project the ID number. We only want to project the name. By indicating 0 ID and indicating 0 for the starting fee, all of the starting fees, then only the type will print. And for $400, we should expect a return of weddings. Hit enter, And there we are returned with the type of weddings, which we know has a starting fee of 400. Let us try the next query. Find all the events and their starting fees. List in ascending order. So this is very similar to the previous question. We are still working with the book fee collection, and we are still working with starting fees, except this time we are looking to find all of the events and their starting fees. So let's go ahead and do the usual command, db period book fee period find. Except this time we are looking to find everything from within the book fee collection, and we are looking to sort. We are looking to sort the starting fee. In ascending order. To sort in ascending order, we need to use the sort command, indicate the value we are looking to sort, and indicate if it's ascending or descending. For ascending it is 1, for descending it is -1. Hit enter, and we return with everything inside of the book fee collection, which is the type of events and their starting fee. The starting fee is sorted in ascending order from the lowest to the highest. Let us try the next one. Find the 3 highest starting fees, list in descending order. So this time we are looking to find the 3 highest fees and list them in descending order from the highest to the lowest. To do this, we can use db.bookfee period find. We are looking to find the 3 highest, so we can use limit. A limit of 3. And then we are looking to sort in descending order from highest to lowest. So we can say sort. Sort the starting fee in descending order. db period book fee period find period limit our return to only 3. Sort those 3, the starting fee, in descending order. Hit enter, and this time we are returned with only 3 different events, starting from the highest to the lowest because they are sorted in descending order. Let us try the last one. Find the first 2 bands with events. Do not output the first event on file. Print in a friendly format. So let us try this. To find the bands with information on file, we need to work with the bands collection. db period bands period find. And we are returned with a list of the first few bands on file that is listed in a regular straight line. Then we have a few other bands on file, and we can tell that they have embedded information because of the information is kind of clustered and jumbled. So if we wanted to print this in a friendlier manner, we can add on the .pretty command. And this will print it in a friendlier format. Everything that has embedded information will print in a breakdown that is easier to read. And everything that does not have embedded information will just be printed in a regular line, in a regular sentence form. So let us try to work with this query and get the information exactly what it is asking us for. We need to do db period bands period find. This time we are looking to find events. So we are only looking to find band that has information about events saved. So we can do event, and we can use the exists operator or command. We can say exists true, and exists true. True is a boolean, either true or either false. So if something is true, we're only checking to see if exists as true. Does this band have information stored in the form of events? Is this true? Yes or no? If it is true, only print those type of bands. So exist true. Limit. Find first two bands with events. So limit to 2. But do not output the first event. So we're looking to return 2 results of bands that has information about stored events. But no matter who is the first band on that list, we do not want to output their information. So we need to use skip. Skip 1. So let's review this again. We are working with the band collection to find event information. We are looking to find information about all of the bands that have events saved on file. Yes, exists true. All that has events saved. However, we are only looking to limit this to 2 bands. Starting from the top, we only want to return 2. However, we would like you to skip the first band on record. So db period bands period find events. Does it exist? Yes or no? Limit the return to only 2. Skip the first. Hit enter. And we return with the 2 bands. However, I forgot to enter the final part of this query. Print in a friendly format. So if you hit the up button, we will get the same command, except this time we need to add pretty. By adding .pretty, then the information will be printed for us in a friendly, readable manner. Hit enter, and there it is. There it is. db period bands find events who exist. Limit to 2, skip 1. Print in a friendly manner, which is the .pretty command. Therefore, instead of reading it in the same format, which is the same information like this, we can read it in a more friendly JSON printable manner. Information, band name, event. There's an event in 2017, Spring Festival, and there's an event in 2017, the Halloween Parade. Band number 2, Kettles, event, the Boardwalk Parade of 2017. Event number 2, the Tribeca Festival of 2018. I hope that you were able to answer all of these queries on your own. And if you were not, I hope that my solution video helped you. This is the purpose of you taking this course, for you trying to learn more skills and advance your knowledge when it comes to databases and programming in different languages. Review each query step by step and try to piece together exactly where you may face problems. In the next section, we will continue working with MongoDB. We will start learning to write queries and how to retrieve data from embedded documents. I will see you then. Thank you. Hello and welcome back. In this section, we will begin to work with relationships in MongoDB. First, let us take a look at some of the relationships we have already created. A one-to-one relationship. We have already created one-to-one relationships at the beginning of this course when we created the bands collection. A one-to-one relationship is any type of relationship where for example, one-to-one is where the parent document has one child and the child has one parent. For instance, we have different bands who performed at different events. But if we had a particular band who only performed at a certain event, and that event was known to only feature a specific band, then that is a one-to-one relationship. Here is another example. We can do a create statement for a new band, and please do this inside of your database. I have already done this and inserted it inside of the database. Soon I will show you what it looks like, but please write the following command and enter it within your database. You are creating a DB bands insert. You are creating a document with stored information. This is a new band, ID number 2. The name is the Wild Wind. Their address is 280 Fifth Avenue, New York, New York, United States. I would like you to create this, and this will be an example of a one-to-one relationship. This band, the Wild Wind, has one address, and let's say, for example, only this band will be able to use this address. This address only belongs to this band. We can say this, for example, maybe they purchased that location and they plan to create all of their music and everything else out of that specific location. It belongs to them. This is a one-to-one relationship. Now, let us take a look at a one-to-many relationship. Let's say we create this new band, and please also, I would like you to create this new band. Both of the examples I show you today in this lecture, I would like you to type out on your own and create it in MongoDB. All of the code and everything you need is right here. So this is a one-to-many relationship. This is a new band, ID number 3. The name of the band is Koi. This band will have a relationship with many different albums. There is an album array, but within this array, there's more than one. There's an album by the name of Yellow, the year 2017, and there's an album by the name of Lamb, year 2018. This is a simple example of a one-to-many relationship. This band has albums. They have many albums. More than one album could belong to this one specific band within our database. Now, let us take a look at the database. In the MongoDB console, I went ahead and I inserted both of those relationships I just showed you. As you can see here, this is the code. This is the image I just shared with you. And if you have not already done this, please do this now. Please create this relationship. Do DB period bands insert ID2 band name Wildwin, address 280 Fifth Avenue, New York, New York, United States. Once you have successfully created this, you will get a successful insert statement. Then create the insert for the one-to-many relationship. Insert the new band, ID number 3, band name Koi, albums, Yellow, year 2017, album Lamb, year 2018. Create this one also. Once you have created both of those relationships, view them in the collection. db period bands period find parentheses period pretty. Hit enter. And as you can see, all of our information from within this collection shows up, all of our bands, and all of our bands with embedded information. So far, we had embedded information about events, but today we created two new bands. First, we embedded information about address, and here's that band, Wildwin, ID number 2, 280 Fifth Avenue, New York, United States, and ID number 3, band name Koi, albums Yellow, album Lamb. This is a one-to-one relationship. This band only exists at this location, and this location primarily belongs to this band. We are just assuming this information for this class. This is a one-to-many relationship. This band has albums. They have many albums, or more than one albums. Also, when it comes to albums within our collection, this band have more than one album, and more than one album may belong to this band. Either way, it is the same no matter how you say it. There's a one-to-many relationship. Now, in the next video, we will begin working with document relationships. A document relationship is the way of creating a new value within a collection and tagging it with a specific ID. This way, when you assign it or tag it with a specific ID, we can connect this almost the same way as using a join statement within a relational database. It is not the same format as using a join. It is just MongoDB version of using a join and the lookup method. I will see you then. Thank you. Hello and welcome back. In this section, we will learn how to write queries for arrays. In other words, how to retrieve data from within a collection who has embedded information. Queries to find embedded information. Let us try a few examples. This is a very easy concept. First, find all bands who performed at the Halloween parade. First, let us take a look at the band collection. By using the prompt db period bands period find period pretty in parentheses and hit enter, we are able to find all of the information from within the bands collection. Any of the bands who have embedded information will be displayed in an easier to read format because we used the .pretty command at the end of our statement. Now, we are looking to find all bands who performed at the Halloween parade. And as you can see here, the last band, well, one of the bands, not the last band, a band by the name of Millie Drive performed at the Halloween parade in the year of 2017. Let us just verify that this is the only band. And this is the only band we have on record who performed at the Halloween parade. So let us write a query to retrieve this information from within the bands collection. To do this, we will say db period bands period find. This time we are looking to find an event. And we're going to use element match. Element match is a method of searching a specific element and finding a match from within the database. Element match event equal to, because we are looking to match something. So therefore, we are looking for something that is equal to. Equal to. The Halloween parade. And it is very important that you enter Halloween parade in the same format that it exists within the database. Halloween parade, uppercase, followed by quotations. Then we want to close the command with 4 curly brackets. And the reason why we are using 4 curly brackets is we use 4 curly brackets at the beginning of this statement. 1, 2, 3, 4. Followed by a closing parenthesis. Now we also want to print this in a friendly, readable format. So we will use the .pretty command. Go ahead and hit enter. And nothing is returned because I made an error and I can see my error. Do you see my error? I automatically see my error and it is a spelling error with event. EVENT. Go ahead and hit enter. And this time we are returned with the band who performed at the Halloween parade. If there's any other parts of information stored within the same document, all of that information will also be returned. So therefore, besides the Halloween parade, this band also performed at the Spring Festival within the same year. Therefore, it was saved within the same document. So even though we are only looking for the Halloween parade, any other event within that document will be returned at the same time. And as you can see, I also made a spelling error, and I just want to point out to you that that is perfectly fine. No matter what level programmer you are, you will make errors. It is always important that you can find those errors and correct them. Now, let us try the second one. Find all bands whose genre is blues. So we're looking for any band whose genre is the blues. To do this, we can say db period bands period find. This time we are looking to find. It is also an event because we saved this information about the event that they played or the genre that they played within the event document or within that array. So we will say event element match genre what is the genre equal to? In this case, we are looking for blues. Four curly brackets followed by a closing parenthesis followed by the pretty command. Let's verify that we don't have any spelling errors, or I don't have any spelling errors. db period bands period find open parenthesis open curly bracket the name we are searching for, which is an event. It is stored within an array. We are looking to match any genre that is equal to blues. We are using the pretty command to print this in a more readable format. Hit enter. and we return with the band, who is the Kettles, and their genre is the blues. Now, I would like you to try 2 on your own. Please try to solve these 2 queries on your own, and in the next video I will go over the solution step by step. Number 1. Find all bands who played at the holiday festival. And number 2. Find all bands who performed before the year 2018. Go ahead and try both of these on your own, and in the next video we will go over the solutions. Thank you. Hello and welcome back. In the last video, you were given the challenge to solve 2 queries on your own. Queries that has to do with retrieving information from within a collection that has embedded information stored within an array. Let us now work to solve both of those queries together. Number 1 said, find all bands who played at the holiday festival. To find all bands that played at the holiday festival, we can say db period bands find event. Because information about any bands that we have stored on file will be saved within the event collection, or document, within the event document, which is an embedded piece of information within the bands collection. So we can say db period bands period find event semicolon curly bracket element match event equal to the holiday festival. Before we hit enter, let us verify that everything is correct. We are looking for db period bands period find. We are looking to find event matching or equal to an event with the name of holiday festival. We are looking to print this information in a easy to read format. Our final statement will be db period bands period find events element match event equal to holiday festival. Period pretty fine. Hit enter. And we return with any band who played at the holiday festival. And as you can see, this band played at the holiday festival in the year 2018. The name of the band is the Snowflakes, and they have more than one record on file that they played within the same year. Even though we did not request the additional record, it was saved within the same array. So if we request a specific record, anything else saved within that array will be returned at the same time. Let us try the second one. Find all bands who performed before the year 2018. Before is the same as less than. Let us write the solution. db period bands period find event element match This time we are looking to match a year or time period. Therefore, year before 2018. Before means less than. less than 2018, close in curly brackets, close in parenthesis, period, pretty. Let us review the statement. DB period bands period find. Event, element match a year less than before 2018. Print in the pretty format in easier to read format. Hit enter. And we return with any band who played before 2018. And as you can see, this one band played in the year 2017, except they have more than one event on file. So even though they have an event on file where they also played in 2018, this piece of information is also being returned. However, we are only concerned with the event from 2017, the event that was performed before 2018. So sometimes in an array, information that you did not request may be returned. However, the information you requested will be a part of that array. It is up to you to find and filter out that information, but know some other parts of information may be included. In the next section, we will begin working with relationships inside of MongoDB. With a relationship, we can connect two collections together to write better queries to retrieve more information at once. I will see you then. Thank you. Hello and welcome back. In this lesson, I would like to go over a document reference relationship in MongoDB. You can use a document reference to create a new relationship, rather than embedding the child document into the parent document like we did throughout this course. For example, we have different bands and we have different events that they performed at. All of the event information was embedded inside of their collection as a document. If we wanted to create a new band, let's say we assign that new band a band ID. We can then have members of that specific band be a part of our musician collection. Each musician will have their own ID, but each musician will also reference the band ID. This is how we will create a document reference relationship. And by doing this, we will know that those musicians are now part of that specific band based on the ID. Let us do this together now in MongoDB. First, let us create a new band. DB period bands period insert open parenthesis open curly bracket. Let us assign an ID of 4. Let us give this band the name of Crave. Close in curly bracket, close in parenthesis, hit enter, and we have a successful insert. Now, if we look at the band table, the band collection, DB period bands period pretty parenthesis period pretty find. We are then given a list of all of the different bands that exist within our collection, and you can see that the last band on the list is ID 4, the band name Crave. Now let us create different musicians and assign them to be part of this band, and we will do that by creating new musicians with their IDs, but then we will reference this ID of 4 as a band ID. This way all musicians will have their musician ID, but they will also have a band ID. This is almost like assigning a primary key and a foreign key in a relational database. Let us create the new musician now. To create a new musician, we will say DB period musicians period insert open parenthesis open curly bracket. Let us assign an ID of 9, because if you can recall, we have musicians in our collection from 1 to 8. So let's continue with 9. Let us give this musician a name of Tammy. Tammy Lee. Let us also say that this musician or skill is a vocalist. And now we need to assign this musician a band ID. And the band ID should match the same ID that we give the band that this musician is a part of, which is 4. A band ID of 4. Close in curly bracket, close in parenthesis. So we are creating a new insert in the musicians collection. ID 9, name Tammy Lee, instrument vocals, a band ID of 4. And by assigning this band ID for this musician, we are linking the ID back to the original band, who has the same ID, band name Crave. Therefore, we are creating a document relationship. Hit enter, and we have one successful return. Let us do this a few more times. Hit the up arrow and backspace. Let us now do ID 10, name. Let us say Rick Miller, who plays the drums. Band ID 4. DB musician insert ID 10, name Rick Miller, instrument drums, band ID 4. Close in curly bracket, close in parenthesis. Hit enter, and we have a second successful insert. Let's do this again. Hit the up arrow and backspace or delete. Let's make this band ID 11. Name. Let us think of another name. Let's say Jess Smith. Instrument. Guitar. Band ID 4. Close in curly bracket, close in parenthesis. Hit enter, and this was also successful. Let us do one more. Number 12, ID 12. Name. Ezra Clark. Ezra Clark, instrument, bass, band ID 4, curly bracket, close in parenthesis. Hit enter, and we have a successful return. Now let us look at the musician collection to verify that all of these were successfully inserted. We already know that they were successfully inserted, but let us view them anyway. Using the command db musicians find parentheses, hit enter, and now we have 4 additional musicians, starting from ID 9 to ID 12, but each one of these musicians have a particular ID. They have a band ID of 4, which reference the band. If we use the command db bands find within parentheses and curly brackets ID 4, it matches the band name Crave, who has an ID of 4. Therefore, we have now created a document relationship. This relationship is a relationship between band and the members of the band. The musicians have an ID that references back the band, and the band has an ID of 4. They both share this same ID. In the next video, we will continue by learning how to create a query to look up information based on this relationship. I will see you then. Thank you. Hello and welcome back. In the last video, we created a document relationship. Now we're going to learn how to query that relationship. In order to query that relationship, we need to use a lookup. Lookup allows us to perform joins on collections in the same database. Lookup works by returning documents from a joined collection on a subquery or array of the original collection. Lookup supports both basic equality matches as well as uncorrelated subqueries. This is a more of an advanced topic in MongoDB. Here I will give you a brief example of how lookup is done, or how we can use this relationship to retrieve information from within the database. However, as you become more familiar with MongoDB, more experience, you should look into and learn more about this feature and different aggregate functions. I will not test you or give you any example practice on this lesson. Now let us try an example so you can see exactly how lookup works and the fields that are required to process a query. First, let us look at the bands collection. I'm actually typing here in the text editor. What I meant to do was type in the MongoDB console. But since I went ahead and type here, please open a text file, either Notepad or any type of text file, because first I would like us to type the command for the relationship query inside of a text file. In case you make any errors while following me, we can simply edit the errors first, then copy the code and paste it into the MongoDB platform. So please open a text or Notepad file before you begin. First, let us look at both of the collections in MongoDB. Here we have the bands collection, and we have all of our information listed of the different types of bands. Now, let us look at musicians. And we have all of the different musicians from ID 1 to ID 12. As you can see, from ID 9 to 12, all of these musicians have a specific band ID of 4, which means that they are musicians or band members of the band who has the ID of 4. And right here, we can see that the band with the ID of 4 is Crave. Both of these we created in the previous video. We created the new band, and we created the new members, assigning them a specific band ID. This is how we created a document relationship. Now, let us write a query to look up information from within this relationship. To do this, we will use an aggregate method, and along with the match to specify the specific artist that we are interested in. In this case, we are looking for artists with an ID of 4. To do this, first let me delete this. To do this, we will say database db period bands aggregate aggregate open parenthesis open square bracket open curly bracket lookup. We are looking up from information from musicians, comma, local field. The local field indicates how we are looking to identify this information. We are looking to identify this information by an ID. Now there's a foreign field. And the foreign field is the field that we are looking for, just like a foreign key in the musician collection. In this case, that foreign field is the ID that we created, which is the band ID. And we're going to use the band ID, the musicians we find, as band members. Now we are looking to match. We need to match together. We need to match together the band that we are looking for. In this case, the name of the band is Crave. We will end the statement the same way we began it, with 2 curly brackets, a closing bracket, and a closing parenthesis. We will then attach .pretty with parentheses to the end of this statement. Let us verify that everything is correct before we hit enter. If you would like to spread this out so it is easier for you to understand, you can do this. You can hit enter, and you can spread the code out so you can view it all step by step. Okay, so let us take a look at this again. We are looking up from the musicians collection. We are Hello and welcome back. Now that we have completed our MongoDB course, we can now learn about how to delete information from within a collection, how to delete a collection, and how to drop a collection. First, let us take a look at how to delete information from within a collection. To delete information within a collection, we can use the command db collection name remove. Within the parentheses, we can identify the field we will specifically like to remove. This will help us identify a specific field to delete from within a collection. For example, we can delete someone by their name. We can also delete someone by their assign ID. We can also delete everything from within a collection by using the db collection name remove command. This time, to delete everything from within a collection, we will leave the parentheses blank. This will indicate to MongoDB that all information from within the collection should be deleted. However, the collection will still exist. To drop a collection, to completely erase a collection out of existence, we can use the db collection name drop command. This will permanently delete or drop a collection. Let us try all three of these examples. Here is the musician collection. As you can see, we have all of the different musicians we have on file. My musician number 1 is already deleted because when I was practicing this video, I accidentally ran that command and deleted musician number 1. It is okay if your collection looks a little different than mine's. Let us try to delete musician with ID number 2. So in this first example, we would like to delete something from this collection. We would not like to delete everything. We will only like to delete one musician with the ID of number 2. So we can say db collection name remove, and we're looking to remove the name. The name of musician with ID number 2 is Larry Kent. So we are looking to remove a musician, specifically the musician with the name of Larry Kent, and I made a small typo. Larry has 2 R's, not 1. Hit enter. And we are returned with a successful remove. Now, if we look at the musician collection, you will see that all of the musicians exist except for Larry Kent. We deleted him by his name. Now let us try deleting someone by their ID. This time, let us delete ID number 3 belonging to Danny Brown. It is the same command, db musicians remove. We are looking to remove by ID, and this time we want to remove ID number 3. db musicians remove, and I made another typo. db musicians remove ID 3. Go ahead and hit enter, but before you hit enter, do what I do, verify to be sure you don't make any typos or any mistakes. Hit enter. And we return with a N1 remove, a successful. So now let us hit up and view musicians. And now we can see that musician number 3, ID number 3, was also deleted. So if you want to delete a specific record out of a collection, you must identify that record in a unique way to be sure that you're not deleting the incorrect document or the incorrect piece of information. Now let's say we wanted to delete all of the information from within this collection. We will basically type the same command but do not include any information within the parentheses or curly brackets. We will say db period musicians period remove empty parentheses and brackets, hit enter, and all 8 pieces of information from within this collection has been removed. Now, if we were to look for the collection, there will be nothing there. Everything has been erased. Now that the collection has been erased, the collection still exists, but it is empty. It is null. There's nothing inside of that collection. Now let us permanently delete that collection. Let us drop that collection so it no longer exists. To drop that collection, you will use the command db period collection name, which is musicians, period drop. And this command will permanently delete a collection. Even if the collection has information inside of it, it will delete the collection. Therefore, before you drop any collection, you must always make sure that this is something you would like to do. Hit enter, and we return with a boolean of true. The collection has now been dropped. Now let us revisit our database. First, let's say show databases. And as you can see, we still have our databases. While I have an admin config local, you should have those too because they're standard. I have an employees database for a different project, but for this project we were using the music database. Now let us look at the music database. We have now switched to the music database. Now let us look at our collections. And as you can see, we only have 2 collections. We only have the bands collection and we only have the book fee collection. We no longer have the musicians collection because that collection has now been erased. It has been dropped. In this section, we learned how to delete information specifically from a collection. We can delete a specific piece of information based on a unique identifier, such as the name or the ID. We also learned how to drop an entire collection by leaving the parentheses or curly brackets blank. We also learned how to drop a collection or erase it in total so that none of the information exists anymore. We have now completed our MongoDB course. In the next video, I will take some time to review with you everything we have learned in this course and some future aspects and different subjects you should be looking into as a MongoDB developer. I will see you then. Thank you. Welcome back. In this lesson, we will learn how to delete information from within a collection using the delete one and delete many method. The delete one method allows us to delete one document from within a collection that matches a specific criteria. For instance, let us first look at the book fee collection. In the book fee collection, we have different type of events, the event names, and their starting fee from $300 all the way up to $600. To use the delete one method, first let's say we were looking for events by their specific starting fee. We can say db period book fee period find So we are saying db period book fee period find. We are looking to find all starting fees in a group, in an array. And let's say we are looking for fees fees of 300, 400, 500. Go ahead and end that statement. Verify that all of the syntax is correct. We have the collection name, find, open parenthesis, open curly bracket. We are looking to find starting fee. The starting fee. In a specific group, we are looking for 300, 400, and 500. Being that this is an array, they are within square brackets. We are ending the statement with two closing curly brackets and a closing parenthesis. Hit enter. And we return with the three different event types that has a starting fee of 300, 400, and 500. And they are being returned to us exactly how they are listed in the collection. For example, 500, then 400, then 300. 500 is the first event on this list based on this query. Now let us use the delete one method to see how it works. We can say db period book fee period delete one. db period collection name period delete one method. And this will delete the first object or the first event listed in this query. Well, actually, we need to identify specifically what we are deleting. I was getting ahead of myself there, but in this case we are deleting exactly what we typed here. We are deleting the starting fee. In 300, 400, 500. db period collection name period delete one open parenthesis open curly bracket. Delete one where the starting fee in the group of 300, 400, 500 will be deleted. When we run this query without the delete one method, this is how they're returned. This is the format they're returned in. So therefore, when we run this query now with the delete one method, we are expecting the very first object ID to be deleted off this list, which is parade starting fee $500. Hit enter. And we have a successful return deleted count of 1. Now let us run that query again to see exactly how this was deleted. So we can hit the up arrow once and hit the up arrow again until we return to the command db period book fee period find starting fee in 300, 400, 500. We want to resubmit the same exact query this time. The find query, not the delete one query, the find query. We want to rerun the same exact query this time to see how the information will be displayed. Hit enter. And this time we are only returned with 2 results. We are returned with the 300 event and with the 400 event because the 500 event that was returned prior has now been deleted. Now let us try the same exact thing, except this time let us use delete many. DB period book fee period delete many, open parenthesis, open curly bracket, starting fee, semicolon, curly bracket, in an array of 300, 400, 500. This is contained within square brackets, closing parenthesis, closing curly bracket, closing curly bracket, closing parenthesis. Hit enter. And this time we have a return acknowledgement of true, deleted count of 2. So now the 2 remainder records in this collection of 400 and 300 has now been deleted. If we hit the up arrow once and hit the up arrow twice to return us to the find method, and we hit enter with the same query of the same values, nothing will be returned because now all 3 of these records has been deleted. First we deleted 500 using the delete one method. Then we deleted 300 and 400 using the delete many method. If we look at the book fee collection, we will now see that those records has been permanently deleted out of the collection. Now we only have records for parties, starting fee at $375, banquet, starting fee at $450, and festival, starting fee of $600. In this video, we learned how to use delete one and delete many to remove records from within a collection. In the next video, we will learn how to use remove and drop. See you then. Thank you.